This is Miss Monson from Shady Brook, and this video is about empty number lines, what they are, and how we use them to solve addition and subtraction problems. One of the big changes in math education is that children are encouraged to use mental math to solve problems and shown different ways to model their thinking. Regular number lines focus on where numbers are compared to each other. Empty number lines focus on your thought process when solving a problem. In third grade, we add and subtract numbers up into the hundreds. We'll start with addition. Let's look at 37 plus 41. There's not one correct way to add numbers on a number line. It's important for your child to develop strategies that work for her. Some kids will start with the 37 because it's first. Some will start with the 41 because it's bigger. When you solve math mentally, you're usually breaking numbers into something easier to work with. So if I start with 37, I could break 41 into 40 and 1. I could add 37 plus 40, land on 77, and then add the 1 and land on 78. Some kids are very comfortable making a big jump of 40. Some would break that 40 down smaller. So I could also start with 37, add 10, 10 more, 10 more, and a final 10 before adding 1. I still added 41 and landed on 78. One mistake that kids make with number lines is they want to make one big jump. They don't want to show their thinking, they want to get an answer down and move on. Let's look at another example, 48 plus 26. If I start on 48, I can't make a big jump of 26 all at once. Where would I even be? Somewhere over 60. Again, there are lots of ways to break this apart. I can start on 48, jump 20 to 68, and then I have to decide what to do with that 6. One way to solve it is to break that 6 apart and use the 2 from it to make a 10. Now we're on 70, and I have 4 more to add. You're looking for easy combinations to add. I tell kids that I'm always looking for zeros. Zeros are my favorite. So if I start with 48, I can add 2 from 26. Now I have 50 with 24 more to add, and I can do that jump in my head. Now I could show you at least 4 more ways to add those two numbers on a number line. But the point is, there's not one correct way to add on a number line. It's all about breaking numbers apart in a way that makes sense to you and looking for patterns. Some parents wonder why this matters. Why can't we just line up the numbers, use the algorithm, and move on? Well, we all make mistakes using the standard algorithm. A kid who can add and subtract mentally is going to catch mistakes that others won't notice. There are also situations where it's faster to solve a problem mentally. I can probably solve this next problem with a number line faster than you could with pencil and paper using the algorithm. If I'm adding 297 plus 154, I'll start with 297. Now, that's really close to 300, and I told you I love zeros. I add 3 to make 300, still have 151 to add, and 300 plus 151 is 451. Done! No carrying required. Next, let's look at a couple of subtraction problems. We'll start with 85 minus 23. The most straightforward way to solve this is to begin with the big number, 85. Once again, we're going to want to break apart the second number. So 85 minus 20 is 65, and 65 minus 3 is 62. Again, that's not the only way you can break 23 apart or solve the problem. The second way I'm going to show you tends to confuse kids the first time I share it with them. I'll start by reminding them that the answer to a subtraction problem is called the difference. And when we subtract 85 minus 23, we're trying to find this piece between those numbers. That's the difference between them. Well, when 23 and 85 are on a number line, we don't have to subtract them. We can start at 23 and add until we get to 85. This will still tell us the difference, the space between these two numbers. From 23, we can add 30 to get to 53, then 20 more to get to 73. Another 10 will get us to 83, and 2 more puts us at 85. Then we take those pieces, the 30, 20, 10, and 2, and add them to find the difference. 30, 50, 62. For most kids, adding up to find the difference on a problem like this is not the most effective way to solve it, but some kids really love adding. Here's another subtraction example. 71 minus 46. We can start on 71, take away 40, so that now we're on 31, And here's where it gets tricky, because we still need to subtract 6. I'd break that 6 apart, take away 1 so that we're on 30. I love those zeros. And then take away the final 5, ending on 25. But let's also try adding up to find the difference, and see if it makes more sense here. We'll label 46 and 71 on our number line, and we're looking for the difference, the space between them. 46 plus 4 gets me to 50. I really do love zeros. 50 plus 21 will get me to 71. 21 plus 4 equals 25, so the difference is 25. The goal of these videos is not to show you every possible way that number lines can be used to solve problems. My goal is to help you understand what I'm teaching your child so that you can support his mathematical thinking, and know why we're learning math this way. My last example in this video is the type of problem I give kids to convince them that number lines can be amazing when we're subtracting. 402 minus 278. Just looking at it, you know that if we stack it and use the algorithm, we're going to have to do some borrowing. And there's a 0 in there. Have you ever tried to help your kids borrow across zeros? Not very fun, is it? So let's add up to find the difference. 278 plus 2 gives me 280. Plus 20 equals 300. 2 zeros, even better. If I add 102, I'll land on 402. Well, 102 plus 20 plus 2 is 124. No borrowing required. You're welcome. This is Miss Monson, and this video is all about using number lines to add and subtract.